This is a lesson on graphing quadratics in vertex form, which you can see right here. So there's my vertex form, and I've actually got an example equation right there. And just like most parabolas, the key point on a graph that you're going to start with is your vertex. And if you have vertex form, the name implies that the vertex should be pretty obvious, and it is. It is h comma k. So in this problem, we have x minus 3, which means that the h value must be 3. And we have y minus 2, which means the k value must be 2. So there's the vertex. It's that simple. You basically just take the opposite of what's going on here and the opposite of what's going on there, and that is your vertex. So let's go to that point. 3, negative 2. I'm sorry, 3, 2. 1, 2, 3, positive 1, positive 2, and there is my vertex. Now the rest of vertex form has to do with this number 1 right there. And you can see down below in the little orange box that I've just highlighted, did it twice, that we have the graph of y equals 1x squared. Now this graph, the orange one that I graphed there, and the equation that I'm dealing with now have the same a value. This is ax squared with nothing extra, and the a value is 1. Here, the a value is also 1. It tells me that these two graphs are congruent. So in my mind, what I like to do, or even on my graph, is I pretend, and I could draw a dotted line anywhere I wanted, okay? I pretend that this point is the origin. And once I have my lines graphed like that, I basically graph those same coordinates as if this were 0, 0. So I've got 0, 0 taken care of. And then from that point would go out 1 and up 1 in both directions. And then I would go again, just to show you, I'm going out 1 and then up 1, out 1 and up 1. And to get to the other points, I would go out 1, 2, and then up 4. 1, 2, 3, 4 puts me right there. So I'm going to be at 1, 6, and then out 2, up 4. And you can see my 4 or 5 points starting to form. I draw my curve, and I've got my parabola. And that's done. Let's check out another one. Y plus 1 equals, let's go with 1/2 x minus 5, and we'll square it. So the first thing, again, we're going to look for the vertex. Vertex is the opposite of this, the opposite of this. There's my vertex. Done. And again, the other key component would be the graph y equals 1x squared. So if you already know what that looks like, you're ready to graph. If you don't, you need to make yourself a little table down here. You can plug in 0, you get out 0. You can plug in 1, you should get out 1/2. You can plug in 2, you should get out 2. And if you wanted to plug in 3, you'd get 9 over 2. Now the vertex there is at 0, 0, so you can mirror over. Whoops. Let's try that again. 0, 0, 1, 1/2, 2, 2. That's probably enough. There's one side, and then go the other way at the same exact heights, and there's the other point, the other side. So I need to make this exact shape at that exact vertex. So this 0, 0 is now moved to 5, negative 1. So I'm going to go to 5, negative 1. Whoa, maybe a little more straight line action there. So let's go to 5, 1, 2, 3, 4, 5, negative 1. So 5, negative 1 is 1 point. And then again, I like to pretend that there's a set of axes right here. Dotted line is fine. And my points on the 1/2 x squared are going to come into play. We're going to go out 1, up 1/2. We're going to go out 2, up 2. And then the same thing the other way. Out, back 1, up 1/2, back 2, up 2. So those are my 5 points, and I try to connect them best I can, and I'm done. So it's really about finding the vertex and knowing a congruent version of that same graph. And that's graphing in vertex form.